Good morning or evening, depending on where you're located. My name is Dain Nilsson. With me, I have my colleague Emil Lundberg, and we both work at Yubico, which is the creator of the YubiKey. Emil is also one of the editors of the WebAuthn specification. Emil, say hello.
Hello.
Today, we are going to start out by covering the current state of account recovery. That is, what services are doing today, as well as what our current recommendations are. Then we're going to talk about some of the shortfalls of some of these approaches. And lastly, we will describe a proposed solution to some of those. So to start out, we have a really quick intro to WebAuthn, just in case you're new. WebAuthn is the standard for using U2F and FIDO2 security keys to authenticate on the web. It's one of the most secure and easy to use solutions that we know of, and a single security key can be used with any number of services. Some of its key points are its ease of use, the fact that it protects you against phishing attacks, and that support for it is baked into the browsers, so you don't need to install any additional software. One of the things that we keep getting asked about is how to handle account recovery in the event that your security key is either lost or destroyed. And each service typically provides some form of account recovery, just as if you were to forget your password. But these mechanisms vary from service to service, and many don't offer the same level of security as WebAuthn does. Some examples include recovery links or codes that are sent to your email or mobile phone. They can include single-use codes that you print out on a slip of paper, or some additional 2FA app. The recommendation that we typically give is for each service to allow their users to register multiple security keys for one account. And we tell our users to register at least one backup security key. That way, the user can themselves use the backup key to access their account. And they can revoke the lost credential, all without having to resort to a less secure fallback mechanism. This also allows a single security key to be used as a backup for multiple services, rather than having a bunch of different apps or code printouts. Now, this approach works well with a single service, but it does have a few scaling issues. Each time you create a new account, you not only have to register your primary security key, but you also have to go and get that backup key from wherever you stored it, and then you need to register it as well. And for each service, you have to repeat that again and again, retrieve and return. So what are the downsides of this? Well, clearly it's a bit cumbersome. I have to go get my backup key from a drawer somewhere and register it. And that kind of makes it a bit error prone as well. It's too easy to forget about that step. Or maybe I registered a new account and I'm not at home where my backup key is, so I'll have to remember to do that later. And yeah, that's the problem that we want to address. So what are the potential solutions that we and others have been looking at? One approach is to make duplicate keys. Just like you have duplicates of your house keys, you could have duplicate security keys. And this could be implemented by allowing the secret key material to be exported from one security key and imported into another, which could then serve as a backup. This would work, but it also introduces quite a security risk. How can I know if someone has already extracted the secret key material from my security key? Maybe even before I received it and started using it. All right, let's take this approach, but see if we can tighten it up a bit. What if the vendor creates a duplicate security key at the time of manufacturing, but then after that makes it impossible to make new duplicates later on? That's better. But again, though, how can I be sure that if I have a single security key, that there isn't a long-lost twin to it somewhere out there? Or what if I do have a pair, but one key is damaged? Well, I can't make a new backup, so I need to replace my single key with a new twin pair to be able to have a new backup. All right, we'll take a step back and start over with a new approach. What if we instead have a cryptographic public key that comes from my backup security key, and that gets installed on my primary key? And anytime I register a new credential using that primary device, the backup public key is registered as well, without actually needing me to get that physical backup security key out of storage. If there's only a single backup public key, then that means that this gets registered with each service. And that breaks the privacy guarantees that WebAuthn gives us. We don't want the security key to become a new way to track users. So maybe we can instead generate a large number of public keys and only use each one once. Sure, that works. But storage limitations will always make sure that that number is fairly low, and eventually you'll run out. And then maybe periodically you can refill getting new public keys from the backup device, but now we're kind of back to cumbersome and error-prone. All right, so if these solutions aren't quite good enough, then what is? Well, what if we start at looking at the characteristics that we would like to see in some ideal solution? Let's start with some ground rules. First up, no less secure. What I mean there is adding our backup solution can't lower the overall security of the system. And that means falling back to a password in that case isn't okay. Next up, no less private. Backup credentials from different services shouldn't be linkable, just like for standard credentials in WebAuthn. Now, some features that we would like to have are set up once. I'd like to do the setup once and then put my backup key away. And as I go around using my primary security key, registering new accounts, authenticating to existing accounts, my backup public key just seamlessly gets added to my accounts, which should definitely be visible to me, but it shouldn't get in my way. And last up, we need to be able to add a new backup. We say it's a setup once, but if I have to use that backup, if either my main key is lost or my backup key is lost, I need to have a path forward where I'm not stuck in a new situation of only having a single key. So I need to be able to, at a later time, add a new backup. All right, does this ideal solution exist? Well, as luck would have it, Emil is here to answer that question for us.
Thank you very much, Dain. And yeah, just to be blunt, the immediate answer to that question is no, the ideal solution doesn't currently exist. But that is what we're hoping to change with our proposal for a recovery extension to WebAuthn. So first of all, let's take a look at how the user experience could look like under this proposal. And then afterwards, we'll dive a little bit more into how it works under the hood. So just like before, we'll start by getting two security keys. But this time we'll say that one of them is the primary and the other is the backup. And we're going to pair the two security keys, either using some kind of vendor-provided configuration tool, or maybe a control panel in the browser or the operating system. And then we're going to just put the backup key away somewhere safe, just like Dain mentioned. And then we're just going to use the primary security key to register and authenticate to as many services as we like, just like normal. And whenever we register or authenticate anywhere, that service will automatically get to know about the backup security key because it's paired with the primary. So now, if you lose the primary security key, you're simply going to retrieve the backup from storage and just use that to log in instead. And since each of these services already knows about the backup security key, this will work. It'll recognize you as you and let you enter your account. Even though the services haven't directly seen this backup key, they have seen that it is paired with the primary. And so, as you go about authenticating with each of these services or adding new ones as you like, the backup security key will become your new primary security key for that service. So over time, as you go about your business, Each of these services will one by one move over to your new key and also automatically revoke access for the one that you lost. So maybe for some time now, you might just have the one security key without a backup, and that isn't great. But whenever you do find the time, you can get a new backup and pair that with your new primary security key. So then you'll again just put the new backup away somewhere safe and just continue using the new primary key. And as you do, again, each of the services will in turn learn about your new backup key because it's paired with the primary. And then this cycle can repeat for as many times as you would like to lose your keys. So hopefully you can agree that this would be a vastly improved user experience over the current situation with no backup solution at all, really. But we also like this for a number of additional reasons. So first of all, much like how WebAuthn works already, there's no limit to how many services you can use with one security key. So even with a small USB device, you won't have to worry about running out of storage space. And also, this design puts no limits on how you can pair your security keys. So you can have as many backups as you want, each of them backing up as many primary keys as you want. And also, a single security key can even be both a primary key and a backup key at the same time. So for example, you and your spouse could make your keys backups of each other if you would like to. And also, you can add and remove backup keys whenever you want. And each service will automatically refresh your backups whenever you authenticate there. And also, this is designed to be vendor interoperable so as to discourage vendor lock-in. And finally, this works without sharing any secrets or keys. And this is not only good security hygiene in general, it also means that backup keys continue to work for those high security applications that rely on hardware attestation. And now this last one might be a bit surprising because it turns out to be very hard to do that with existing standard cryptography. But there is a lesser known technique that we can use for this. So let's take a look at how that works at a high level. So like I described earlier, we're going to start by pairing the two security keys. And this means that the backup device will generate what we call a public backup seed, and then send that to the primary device. And the primary device stores the seed. And then the primary device can use this backup seed to generate new public keys, backup public keys, that is, on behalf of the backup device. And now, along with the backup public key, it also will send a backup key handle that the server stores. And this key handle is much like a credential ID in WebAuthn. And then after you lose the primary device, you would ask the service to log you in with a backup credential instead of a standard credential. And then the server will send the key handle down to the browser, and the backup security key will use the key handle in combination with the backup private seed in order to derive the corresponding credential private key, and then use that private key to authenticate. So, in summary, in this way, the primary device first generates and registers a backup public key, and then the backup security key derives the corresponding private key and uses that to authenticate. So even though the two security keys haven't directly communicated since the pairing, this connection works as to do that. And the important point here is that throughout all of this, the primary device never knows the private key. So the basic idea behind this isn't entirely new, but we weren't able to find a formal proof that it's actually secure. Fortunately, we were able to partner with a group of cryptography researchers and find a formal security proof. And I want to give them a big thanks for that. So very big thanks to Nick Fryman, Daniel Gardam, and Mark Manulis at the Surrey Center for Cybersecurity, and to Franciscus Kiefer at Wire. Thank you all very much for helping us do this. So the bad news then is that this is still only a proposal, and it's still going to take a while before you can actually use this. So the proposed protocols will need to be reviewed and revised and ultimately accepted. And then both security keys, browsers, and web services will need to implement support for it. And software libraries will be able to help a bit, but not all the way, unfortunately. But on the other hand, this is where all of you come in the audience, because WebAuthn is an open standard, and we want this to be an addition to that standard. So you're all welcome to come help us make this better. So what are your thoughts and ideas? How should this work? What have we missed? And what else needs to be clarified? Because we want this to be usable by anyone. And it will only work if people actually want to use it and support it. So please do come help us and make this the best that it can be. And you can do that at these links that you can see in the slide here. So please come join the discussion. We would be very happy to have you. So in summary, WebAuthn is great, as we all know, but unfortunately the backup user experience isn't great. And there are a bunch of other solutions that are being worked on, but unfortunately, most of them have some kind of drawback in some way. That's not to say that this doesn't have any drawbacks, but we think that it at least can plug the gaps between the other solutions and work as a generally available solution for this, is our hope for this. A lot of work remains to be done, but yeah, you're all welcome to come help us. And with that, we would like to thank you for your time and attention, and we're very happy to take your questions.